Oh, that would be interesting. Oh, Mars. Life. Life in Mars. Mars is life. Mars is life? Hello everyone, let's start! Yeah!
Mars, a red hellscape of ionizing radiation, toxic soil, and the recent target for invasion by a sadistic, nigh unstoppable, evil, demonic overlord in the game that's the topic of today's video.
Wow, the opening of this video is super dark. And also super nerdy, so...
Surviving Mars! And it's me. I'm the sadistic evil overlord. Make way for my army of bionic colonists! Bionic colonists who never die and never cause food shortages! Anyway, I've just been informed that Surviving Mars is a game about presumably colonizing Mars and not actually creating a bionic utopia built upon the bulging corpses of dead, strangulated organic humans, and with the expansion being about scaling this occupation up from merely living in fishbowls to actually terraforming the entire freaking planet for human occupancy. Paradox Interactive came to me and was like, hey, would you like to do a video on this? We will pay you. To which I said, you've seen my show, right? This one? This show right here. And they weren't dissuaded somehow, fools! So anyway, I was like, yeah, sure, I'll check your game out, I guess. What's that? It's like Dwarf Fortress, but in space? Aw, shit! Would you guys stop having so many babies? I can only build so fast! So, yeah, about 150 hours in, 150 hours that I definitely needed to research this episode. I can quit micromanaging, designing, and maintaining a colony that entirely uses oxygen provided by plant life anytime I want! I'm not addicted! You can't prove anything!
I'm not addicted! You can't prove anything! Yeah?
Please press F to pay respects for my wife, the surviving Mars widow. In any case, with the world the way it is, what with global warming, the supervolcano underneath Yellowstone, the over 14,000 nuclear warheads in the world, and thousands of other potential threats, one might be tempted to head off into the stars in search of a home far from this one. So to that end, we're going to give you a step-by-step guide to successfully terraforming Mars for human occupation, just like you can do in Surviving Mars Green Planet. And it's gonna involve addressing three main concerns: building up the atmosphere, raising the temperature, and closing the portal to hell. Oh, crap, this is freaking wrong game again. I meant make the atmosphere breathable.
Alright, so building up the atmosphere, raising the temperature, and make the atmosphere breathable. You need to breathe after all, so...
Step 1! Blot out the sun! Okay, no, not really, but some of you may know that it's been theorized that Mars used to look a lot like Earth before it looked like, well, this. What happened? Solar wind blew away the atmosphere. It's possible that millions of years ago, Mars had oceans and clouds and colors other than this rusty red, but...
And the possibility have increased a lot due to the fact that we just landed a new rover! Helicopter on Mars! So yay! Helicopter on Mars. This is a drone. It is a drone, so technically speaking.
Then the core of the planet cooled and solidified, and electrons stopped moving around freely, and bam! The magnetosphere just up and left. You see, magnetism is created by electric currents, the moving of electrons. Our own magnetosphere is believed to be created by electric currents in the core of our own planet, created by the motion of molten iron in the outer core. our core is, very hot. Believe it or not, this is actually all leftover kinetic energy from when our planet first formed, created when all those molecules squished together to form this ball we live on. Mars, too, had one of these, but being about 1/10 the mass of Earth had way less energy to spare, so its core cooled millions of years ago, that iron seized up, and bingo, bongo, no more magnetic sphere. This is bad news, because the magnetic field generated by planets deflects and suppresses the pressures induced by charged particles leaving the sun.
The solar flares and especially the solar flares and the solar winds. So it's very important. To our knowledge, it's very important.
Particles that otherwise slam into a planet going 1.5 million miles per hour, or over 2.5 kilometers per hour for you filthy, okay, actually everyone else other than us. Before we can go about dealing with any of the other challenges, replacing the atmosphere, cleaning the toxic soil, warming up the planet, we have to deal with this issue. Because otherwise, any atmosphere we try to make is just gonna get blown away by solar wind the instant we create it. Like the sun is the biggest toddler in the universe, and Mars's atmosphere is an unmolested dandelion in the grass. Now, replacing a planetary scale magnetosphere sounds like a monumental task, and yeah, it is. But there are actually many proposed solutions. One involves installing 2 super-cooled electromagnets, one at each pole, to basically artificially recreate the magnetosphere, which is,
well, we have not tried it, so we don't necessarily know, or maybe just boom, the entire planet. Yeah, that is actually a legit solution that people actually come up with. Yeah.
actually a solution mimicked in surviving Mars with placeable magnetic field generators on the ground. I couldn't think of any specific reason why the magnets would necessarily have to be at the poles, so that checks out. There is, however, a way more interesting solution. My favorite solution is one that was devised at the Planetary Science Vision 2050 workshop in 2017, and hey, also exists in Green Planet. It's one that involves basically creating a freaking electromagnetic shield in space. This would be achieved by placing a giant electromagnet at what's known as the L1 Lagrange point between Mars and the Sun, which is... Hey, do we have time to explain Lagrange points?
Please explain to me. I'm very, very interested about it.
No? I've been talking about magnets too long. You don't. But they're really cool. It's either like this thing where you can like park a satellite in a spot where the gravitational pull of one body and another cancel out, so like it remains stationary there, where ordinarily something that's 1 billion meters closer to the sun than Mars would have to like have a faster orbit, but it actually like stays in place because of physics.
Because physics.
No, I can't explain that. All right, we'll just edit this out. The magnet would remain parked between Mars and the Sun, and its magnetic field would deflect incoming solar wind without having to envelop the entire planet. That's pretty neat, huh? The Lagrange point 1 from Mars is actually 1 million kilometers away, which for context is almost 3 times the distance the moon is from Earth. Here, particles heading straight for Mars would have to be deflected merely 0.179 degrees in order to miss the planet entirely. That's not too bad. Unfortunately, magnetic fields created by electromagnets like the one you can launch in Green Planet diminish in strength exponentially, not linearly, meaning that while you can deflect quite a few charged particles coming straight at the center of Mars, if your field doesn't extend high enough, you're not really accomplishing much. The work done by the Planetary Science Vision 2050 workshop estimated that the strength would have to be measured at about 50,000 nanoteslas, a whole Earth radius away from its origin point. And, well, to be honest here, giant cosmic magnetism mathematics is complicated. I burned an entire day trying to learn it and got basically nowhere. So, I'm gonna do...
And also, for example, not sure if you know this, Sun is way bigger than the Moon, than Mars. So yeah, even though the illustration over here shows that Mars and Sun is like around the same diameter, in actual fact, sun is like super big and the Mars is like super small. So yeah, the more you know.
Something I don't ordinarily do, and I'm gonna rely on the math done by someone else. Stack Exchange user AsDefects, AsDefects? Math done by Stack Exchange user AsDefects to estimate the power and material requirements necessary to build a magnet that accomplishes this task. AsDefects, after running the math, figures a magnet would have to be built using a coil that's only 12,000 kilometers long. In order to create a magnetic field, we have to run electricity through this wire. Simple enough. A wire 1 meter thick would require only about 10 megawatts of electricity to create our magnetic field. Bam! Unfortunately, this would require 3.3 billion tons of copper, which is the equivalent of over 187 years of our current max copper production to complete. The one I can make in surviving Mars only requires 80 metal though. What's that about? I guess we can reduce the size of the wire needed, but therefore we need to increase the power we pump through it proportionally in order to create the field. If we shrink the wire all the way down to 10 centimeters, just short of 4 inches wide, it would only take 2 years worth of our total copper production to create. Way more achievable.
Achievable and also quite feasible at the current pace that we are doing it.
Still not 80 metal small unless each unit of metal is actually short for 422 metric tons, in which case the guns on those drones are epic. I'll let that slide though because I've been playing the game for about 150 hours and across like 50 in-game generations, and still I only have like 30,000 tons of metal. Shrinking the wires raises our power requirement from 10 megawatts to 1 gigawatt, which we could maybe use solar panels for, but since the intensity of sunlight diminishes according to the inverse square law, even though Mars is only 1.5 times further from the sun than Earth, sunlight here is half as powerful. Less than that even, just 43% the strength. And even with impossibly efficient solar panels, you would need over 600 football fields worth of solar panel surface area to collect enough sunlight energy. But all is not lost. If we just built 2 relatively tiny nuclear reactors the size of the Palo Verde plant and run them at full capacity 25 hours a day, then we can do it. We can finally protect Mars using the powers of science! Woo! I've been talking a lot about magnets, but honestly, this is the biggest problem, hands down, with terraforming Mars. If we can solve this one issue, then everything else becomes a relative cakewalk. And since our own core is cooling at a rate of about 100 Celsius every billion years, this may be something we want to keep in our back pockets. Okay, so one major challenge down. Build a giant electromagnet in space with 33 million tons of copper you have laying around. Check! All right, what's next? You gotta raise the temperature. With solar wind out of the way, we can actually start impacting the atmosphere. Mars's atmosphere is absolute crap. It's why you gotta live in bubbles like in Surviving Mars if you want to colonize it the old-fashioned way. It's composed of 95.32% carbon dioxide, 1.9% nitrogen, 1.6% argon, and 0.13% oxygen.
Wow, we really need to change it significantly. Wow.
And it's just 0.5% as dense as Earth's. And if you're like me, your first thought is, oh, CO2, plants like that. I learned that in school. And plants make oxygen using photosynthesis. And you're right. However, they tend to not like it when it gets down to 82 below freezing every night. We gotta warm this planet up somehow if we're gonna have any hope of letting a human walk around in something other than a fully sealed spacesuit. Thankfully, as you may or may not know, warning planets is our speciality. We just gotta bombard, and I mean bombard the planet with greenhouse gases. How hard can it be? Really freaking hard, it turns out. Greenhouse gases work by absorbing radiation from the sun and then re-emitting it as infrared light, which is more likely to stay trapped within our atmosphere. We have a couple of things in our favor here, thankfully, one of which being that the polar ice caps on Mars actually have a bunch of CO2 in them, which, as you know, is a greenhouse gas. So the act of just warming up the atmosphere will actually encourage more CO2 to sublimate into the atmosphere.
Yes, especially from, okay, I've read the book from Bill Gates, How to Avoid a Climate Disaster. That book, I think so, around there. Too much of it is bad, too little of it is bad. Just nice is perfect, you know.
Create a self-reinforcing cycle that'll work for us. There's over 2.8 billion tons of CO2 locked in the ice caps, and if we were able to heat the planet enough to melt them, which wouldn't necessarily be impossible if we redirected asteroids and comets, and oh hey, that's another thing Paradox thought of, and if they're filled with nitrogen and argon and we introduce them into Mars's atmosphere, this could raise the atmospheric pressure all the way up to 60% Earth's, meaning you could step outside as long as you had a sealed helmet and the water in your body wouldn't immediately boil away. Combine this with throwing away all our modern clean air policy plans with factories in Green Planet that generate greenhouse gases from waste rocks, fuel, and carbon sources on the planet, and FedExing gases from Earth, something you can do if you eat those steep shipping rates. This might actually be doable. Alternatively, you can also literally nuke the ice caps from orbit like in Surviving Mars, which would probably actually work to release a bunch of water and CO2 as long as you don't mind picking out radioactive fallout from your salad. I'm gonna be honest with you, I am not a terraforming expert. Most people aren't because we've never done it before. So exact numbers are really hard to come by. But if we could get Mars to this point, we could finally start on the hardest part, making the atmosphere breathable. Okay, and it's here that you might think it's time to plant trees, because CO2! Trees love it, and maybe it's warm enough to plant some Christmas trees, but no! We spent 5 years constructing a giant magnet to shield the planet, another what, 20 to 30 finding asteroids and comets, redirecting them in order to heat up the planet enough to melt the carbon out of the ice cap, and we still can't plant trees yet? No! Because trees still require oxygen. Stupid trees. What are they even good for? But you know what does not require oxygen in order to engage in photosynthesis? Cyanobacteria. Cyanobacteria were the bacteria that were probably responsible for the original rush of oxygen into our own atmosphere. You see, prior to this point, the Earth, it looked a lot like a half-terraformed Mars.
Wait, what? Seriously? That means that bacteria is super useful in helping us terraform Mars. Interesting.
Kind of cold and full of CO2, and then BAM! Photosynthesis. Simple organisms like bacteria don't have all the complex moving parts of trees, so they can quite literally just make oxygen out of CO2 using just water, which hopefully we can find some, and sunlight. These incredibly resilient little buggers flooded the Earth with oxygen so quickly that it's literally called the oxygen catastrophe by scientists, because, hey, turns out on a planet where life didn't evolve using oxygen to breathe, being flooded with oxygen can be incredibly deadly. Oxygen loves to react with stuff, which is chemistry speak for bond to other molecules and fundamentally change how they operate, which can be kind of bad for organisms that are made of only a few molecules. Hey, I needed that! Oh, nope, I'm dead now! I could not find estimates for cyanobacteria oxygen production, but we need a lot of them. Photosynthetic algae, similar to cyanobacteria, produce conservatively 70% of all oxygen on Earth, and it took like freaking 500 million years to produce our current atmosphere. Surviving Mars deals with this by growing lichen, which is actually a happy marriage between algae, cyanobacteria, and fungus cohabitating in one giant, kinda gross clump. This is actually pretty brilliant because
this is actually pretty brilliant. Even though it took us millions of years, it will probably take it's not millions of years. It probably took us hundreds of millions of years. If we plan it properly, we might actually not need hundreds of millions of years. We might actually just need a million or 2 years or a few 100,000 years. You know, it's still a big number, but it's doable, it's feasible, I guess.
Well, not only does lichen have cyanobacteria and algae already, but fungus is more resilient to radiation and could help shield algae and cyanobacteria from deadly cosmic rays while we wait for enough oxygen to build up an ozone layer. An imported colony of, just a few hundred tons of lichen biomass could probably produce enough oxygen on the planet in only, 100 years, and then we'd be good to go. Well, sort of. Honestly, we don't need that much oxygen to breathe, but we need dramatically low CO2.
But first things first, we need to develop the technology to send it to Mars to propagate. So, yeah, still the 1,000 years range.
Levels to breathe. That's right, the very stuff keeping our planet warm is fatal to us at percentages as low as 2%. So even if we could raise the oxygen levels to 22%, we'd have to eventually get rid of all that CO2 if we ever wanted to live comfortably on Mars. And can we sacrifice it with Mars's lower surface gravity? Can we maintain the pressure and heat required to keep us alive? Who the hell knows? This is all ignoring the toxic soil filled with frickin' chlorine and the possibility that a surface gravity as low as Mars's would have terrible consequences to human biology. All said and done, giving us every benefit of the doubt and concerted efforts, and it'd take us at least 200, maybe even 500 years to come close to making Mars habitable in a light jacket without a mask, and probably
Conservative number.
Thousands to hundreds of thousands to be an actual safe place to be and to allow for human evolution to accommodate the different environment.
I knew it. It had definitely got to be in the thousands of range. I knew it. Yay. Minimum thousands of range. Minimum.
It's not impossible, probably, but it turns out it's not a viable escape from the issues we're currently facing. The timescales of things like global warming and nuclear annihilation are decades, not hundreds of years. It turns out we'll just have to deal with our problems first, like grown-ups. Doesn't mean we can't fantasize though. And I guess some things are best kept in fiction, like in Surviving Mars, which does, in fact, deal with a lot of these things in its expansion green planet. Even stuff that I didn't get into, cause hey, guess what? Terraforming is freaking complicated. You have to balance atmospheric temperature by pumping out greenhouse gases. You have to evaporate water and fertilize the soil so you can grow trees, which can produce oxygen, and maybe someday your colonists, if they're not dead like mine, will get to walk around in the open air. Sounds nice. That is, until I somehow screw it up by lighting the atmosphere on fire or causing my own runaway global warming problem. Check out the link to buy the game in the description and send me updates on your colony on Twitter so I can judge you from on high. Sincerely, Austin.
Oh my gosh, man. Sincerely, Austin. Wow. Oh my goodness. Wow. Oh no. Thank you so much for watching this video. Thank you so much. If you do like this video, please consider to like, share and subscribe to my channel and comment down below if you have anything to share with us. Do remember to follow my channel as well. Thank you so much. This video that I just reacted to came from the YouTube channel, The Game Theorists. This video came out in the year 2019, which is around 2 years ago, and there's a lot of different progress in technology after then. So, yay, humanity! Yay! Thank you so much, humans. Anyways, I sincerely appreciate that all of you show support and watch more of their videos from the YouTube channel, The Game Theorists, and show appreciation, show support for them. Thank you so much, and I'll see you next time. But hey, that's just a theory. A game. It's not a game theory. It's the science of. But hey, that's just a science. The science of. Thanks for watching. Signs of surviving on Mars. Yeah.